He worked as a research associate at University of British Columbia, Canada in 2018. On behalf of Department of Computer Science and Engineering, Excel Engineering College, I would like to welcome our today's resource person, Ajay Kaushik sir. Welcome you, sir.
Thank you, ma'am.
Now the session is handed to our resource person. Please, sir.
Sure, ma'am. Hello, a very good morning to all of you. Thank you, Geeta ma'am, for the kind introduction. We had a session on big data analytics and applications of big data analytics previously on December 16th. We will be continuing on where we left in that particular session. I will just open the PPT for you. Yeah. I hope that my screen is visible to all of you.
Yes, sir.
Okay, thank you. To just start with, dear faculties and friends, to just start the session, I will just introduce that what we have on the, on the introduction and what we are going to study today. First, I will give a brief introduction on the big data analytics for those who have joined in this particular session only. And after the introduction part, we will just continue from where we left on December 16th session. And in our session number 1, we will be studying some very useful and interactive PPTs regarding big data analytics and its applications in real world scenario. And in the afternoon session, that is session number 2, we will practice some tools, some hands-on practices, and some important software connected to big data analytics and its applications in real world scenario. So to just start the session, I'll just start at what we are going to cover in this particular presentation. That is what is big data, how it is. As I just told you earlier, I will just give a brief introduction to big data and its analytics part before I pick up from where I left on December 16. So what is big data, how it is different from small data, how will it impact our lives, and how it is a good thing, how can librarians prepare. Uh, to just come straight to the point, yeah, we have two types of data here. First is the quantitative data. Quantitative data is the one that is measurable, collected through measuring things that have a fixed reality, close-ended. Whereas on the other hand, qualitative data is descriptive in nature, collected through observation, field work, focus group interviews, recordings, or filming, and it is open-ended rather than closed-ended. Then we introduce the concept of big data. Data is too big or too complex to be managed using traditional data processing. Now, this slide basically explains that why we require big data and why this concept was introduced, because the traditional data algorithms that we had, they were not working efficiently with the growing size of the data. Nowadays, we have Facebook, YouTube, Google, and many interactive online websites. And even Facebook and Google and YouTube, they collect, process, and manage exabytes of data per day. We all upload videos on YouTube, and it's quite incredible that how the YouTube server manages all that huge amount of data, because people from all around the world are uploading videos on YouTube, isn't it? And the size of of that particular file that is being uploaded can be, of from MB to GB to even TB. So that's a huge amount of data, and how the YouTube servers are able to manage it, process it. That's quite an incredible thing. So this is an example that why we required big data, because the size of the data increased quite incredibly over the time or the years. And processing that data, storing that particular data, trying to find out a particular file from a huge chunk of data require a huge effort and very efficient algorithms to perform those tasks in a specific amount of or a specific period of time. So to perform all these operations, we needed some efficient algorithms or tools that could, play with huge amounts of data. And there we introduced the concept of big data. Uh, Now we define big data with four V's that are the four pillars of big data. That is the amount of data, types of data, means which type of data are we dealing with or which type of data are we processing, the frequency of data, and the quality of data. I will explain all of them one by one. Volume is the scale of data, as we can see, as I just explained you earlier as well, that size of data is growing exponentially from bit to byte to kilobyte to megabyte, gigabyte, terabyte, petabyte, exabyte, zettabyte, and yottabyte, and see how much data a yottabyte contains. So scale of data or the volume of data is increasing by every day. 90% of today's data has been created in just last 2 years. Every day we create 2.5 quintillion bytes of data, or enough to fill 10 million Blu-ray discs. That's a huge amount of data. 40 zettabytes or 40 trillion gigabytes of data will be created by 2020, an increase of 300 times from 2005, and the equivalent of 5200 gigabytes of data for every man, woman, child on earth. Most companies in the US have over 100 terabytes of data stored. And 100 terabyte is a big amount of data. So this particular slide explains about the volume that we are dealing with in present age. Variety is, as I told you earlier, that we have to understand and know which type of data are we dealing with to process it properly. According to me, big data and big data analytics not only contains the concept of only storing the data, because if you store a huge amount of data and you are unable to find out a particular file, a particular chunk from that huge amount of storage, then storage is meaningless. So in order to develop or prepare efficient tools to extract useful information within a given or specific amount of time, we need to understand variety of data or which type of data are we dealing with. As we can see, there are different types of online tools shown in the slide, like WhatsApp, YouTube, Google Plus, Facebook, Spotify, Messenger, Instagram, Flickr, etc. They all process and deal with different kind of data like text, images, multimedia. So we have to divide them into specific different classes. This is a status up to 2016, and you can see that how much every website or every online tool is creating the volume of data. And and this is 2016, we are into 2021. So you can just say that amount of data doubles itself every 2 years. So you can easily imagine that how much data that we will be having by today, that is 2021. Velocity, that is analysis of streaming data, that is how fast our data can be streamed and processed. Veracity, that is trustworthiness of data, that is the origin of the data, from where the data is originating. Authenticity of the data, authenticity, and along with that, trustworthiness of the data. completeness of the data, and integrity of the data. Now, integrity here is a very important factor in big data analytics. It is, if I'm transmitting a data or data chunk from your machine A to machine B, or from one end to another end, then the data that I sent from machine A should be the same that to the data that I am receiving on machine B. So, the data should not be altered with, the data should not be tampered with, and all these factors jointly contribute to the integrity of particular data chunk or data piece. Uh, Again, the same thing, there are four V's of big data that I have already explained to you. Big data and research, big data mining, collect big data to obtain access to repository, perform data analysis to explore patterns, pattern recognition, predictive analysis. See, dear faculties, what we are studying here is big data analytics. But if we only study analytics part and only study the theoretical part, that will not be of big use in today's present age. So in this particular session, especially in the afternoon session, my main focus will be on the research part of big data analytics, that how we can use big data analytics in the research, and how it can be useful for us in writing good research papers, in filing good patents. I will also show you one of my patent that is being recently accepted on this particular area, big data analytics. I will show you that how I prepared the algorithm for that patent and what tools and algorithms are used using big data analytics. My focus will be on the research part as well, along with the theory portion, because in today's age, research matters a lot. So just continuing in the slide, we can perform data analysis to explore patterns, that is pattern recognition, predictive analysis, identify potential correlations, and these are some of the basic parameters of big data research. And we can see many students, PhD students, working on these particular areas. Big data in healthcare, faster and cheaper technology and data storage, widespread sensing devices, an increase in born digital data, greater availability of data via repositories, data sharing mandates, faster and cheaper technology and data storage. The cost to sequence a whole human genome sequence has fallen from 100 US dollars, uh, US dollar 100 millions, to less than $1,000 over the past 15 years. So this particular slide shows the effect that big data research has on in the healthcare industries all around the world. And then we have the sensing equipments, smart watches, we have smart jewelry, fitness trackers. Before explaining this particular slide, dear faculties, I would like to, mention a very important thing here. If we are dealing with big data alone, or if we are working only with big data or big data analytics, that can be useful, but it will not produce a good amount of research, because research always contains two disciplines. That is, if you combine, uh, I think all of you may be beware of this, because I am talking to some good researchers here, and that if you combine two areas or two disciplines and try to combine them into one and then produce some good patent or research or a funded project, then the quality of that paper or patent improves. Now, why I'm saying that we can merge two areas or two specific, algorithms to produce good research, because here the title of the slide is sensing devices. Sensors produce a huge amount of data every day. 5G has been introduced, and we are expecting the introduction of 6G as well by possibly 2024 or 2025. In India, 5G is still not implemented, according to me, as per my knowledge. But in UK, US, China, Australia, 5G has started implementation. And the basic advantage of that 5G is it reduces the latency by speeding up the processing speed. That is, processing speed is high. So why I'm talking to you about 5G and 6G? Because 5G and 6G forms or is a part of IoT structure, Internet of Things. And what are the backbone of Internet of Things? Sensors. And sensors produce massive amount of data every day in our daily lives. So if we combine these two fields, that is big data analytics along with IoT or along with wireless sensors, this will make a fantastic area of research to work upon. Many of the researchers are already working in this area, and you can publish and file many patents on this particular area. If you just go to IEEE, you will find some very good papers in which these two areas have been combined. So I would, say to you that please don't see big data analytics as a single type solution. You have to combine it with any other discipline as well to make it more meaningful, to make it more interactive, and to make it more useful for the research purpose as well. In the afternoon session, I will be explaining you that how we can efficiently use the data generated by various sensors to apply Hadoop and big data analytics algorithms to it. Uh, so continuing on this particular slide, smart watches, smart jewelry, fitness trackers, sport watches, smart glasses, smart clothing. All these includes big data algorithms because wherever we see a big amount of data or data mining, we will see the use of big data analytics there. An increase in born digital data, data that originates as digital data rather than being converted or digitized later is is proliferating. Thank digital electronic medical records, implanted medical devices, diagnostic images technologies. So there is an sudden increase in digital data due to the various devices that use wireless sensors. Uh, as of April 2016, the registry of research. So this particular slide again shows the greater availability of data via repositories, basically in healthcare system. Then we have sharing mandates. The number of funders and journals with data sharing policies has grown significantly in the past decade. The healthcare big data horizon, the leverage and electronic health record to improve diagnosis, outcome, and reduce costs. Integrate patient generated health data and the Internet of Things. It is the same thing that I was explaining you earlier. Incorporate environment and socio-economic data in patient diagnosis and treatment. Develop personalized care specific to each patient's particular needs. That is also called as the precision medicine phenomena. That is specifying a particular cure or cure to a specific patient according to its ailment or disease. So in that particular area as well, the big data analytics will come very handy and useful. Health disparities, big data to the rescue. Of course, big data will be quite, or in fact, big data is quite useful in health disparities as well. Big data, this particular slide shows the instances of big data with the increasing amount of years. As you can see that the use of big data has increased. In 2008, it was introduced or produced in the market. with a big boom, but since the knowledge and expertise of the people were not quite good, so in 2009 and 2010 it was a slight dip, and after 2011 it has shown an exponential increase in the healthcare system. Hurdles and risks. Unstructured data, that is 75% of the data in the healthcare environment. Data privacy, security, HIPAA compliance, patient confidentiality, personally identifiable information, inconsistent, incomplete, unavailable, poor quality or invalid data, poor analysis, analytics leading to. Okay, so from this slide, I would like to explain you another thing. I told you earlier that we should try to merge two disciplines together to form a good research. Earlier, I told you that we can merge big data with IoT or along with wireless sensors or 5G, and these two areas combined will produce very good research. Here, in point number two, it has, uh, you know, given hint to another hot area of research that is being quite, regularly used in every domain, that is privacy and security of data. Now, with the introduction of technologies, sensors, websites, the amount of data has grown, and we have introduced the concept of big data. And big data, what it does, it stores the data efficiently, it processes the data efficiently, and it handles the data and data processing algorithms in the best way possible. But there is another factor called privacy or security that is very crucial in big data. So if we can combine big data analytics with privacy and security algorithms, that will be quite useful. I hope all of you have heard the concept of quantum computers. And quantum computers are under process in US, and they are expected to be introduced into the market by 2022. This is an expected time period that they have given. And the advantage of these computers are that they are very fast. The algorithm that our normal computer can perform in 2 days, quantum computers will be able to perform that particular algorithm in 2 minutes. This is how fast quantum computers will be. And although this is a big advantage because obviously speed will be increased, dear faculties, but along with the advantage, there will be an issue as well. Since the processing power of quantum computers is huge, is very good, all the privacy and security algorithms that are presently used in our banking system, in our healthcare system, or in any discipline of the society, all those security algorithms will be compromised. And quantum computer can break any encryption algorithm very easily. And this will be a big issue after the introduction of quantum computers. So this is another area of research that we have, that how to manage big data with data security, especially in future IoT structures. This is an open area of work or open area of research on big data analytics. Then we move forward, big data and the librarians. This is not very useful. I'm just going through the introduction to this big data concept. Continuing to the introduction part, dear faculties, massive sets of unstructured, semi-structured data from web traffic, social media, sensors, etc. comprise big data. Petabytes, exabytes of data, volumes too great for typical DBMS. Okay, this is another point that we use DBMS. is database management systems to store and process normal data, but the volume of big data will be too high to be handled by DBMS. So, as you will see in the upcoming slides, that we have a separate or new storage processing system for big data. Information from multiple internal and external sources, that is, transactions, social media, enterprise content, sensors, mobile devices. In the last 60 seconds, there were 204 million email sent, 61,000 hours of music that people are listening to, 20 million photo viewed, 100,000 tweets, 6 million views, and 277,000 Facebook logins, 2 million plus Google searches, and 3 million uploads on Flickr. So this is for last 60 seconds. So from here you can imagine that how the data is growing exponentially. Uh, Companies leverage data to adapt products and services to meet customer needs, optimize operations, optimize infrastructure, find new sources of revenue, can reveal more patterns and anomalies. IBM estimates that by 2015, 4.4 million jobs will be created globally to support big data. 1.9 million of these jobs will be in the US alone. Where does big data come from? That is the origin of big data. First, we have enterprise, that is the dark data, partner, employee, customer, supplier, public, commercial, social media. These are some of the origins of big data that we have. Then we have types of data. As I told you in the previous slide as well, that is the variety of data is important here. When collecting or gathering data, we collect data from individual cases on particular variables. A variable is a unit of data collection whose value can vary. Variables can be defined into types according to the level of mathematical scaling that can be carried out on the data. There are four types of data or levels of measurements: categorical, ordinal, interval, and ratio. Categorical data is data that comprise of categories that cannot be ranked ordered. Each category is just different. The categories available cannot be placed in any order, and no judgment can be made about the relative size or distance from one category to another. For example, customers location, that is where a customer is placed; employee classification, that whether a employee is manager, supervisor, or an associate. Then we have nominal data. Systems for measuring nominal data must ensure that each category is mutually exclusive, and the system of measurement needs to be exhaustive. Now, what is the meaning of exhaustive here? Exhaustive, the system of categories system should have each enough categories for all the observations. Variables that have only two responses, that is yes or no, are known as t- taxonomies. Then we have ordinal data. Ordinal data is the data that comprise of categories that can be ranked in a specific order. Similarly, with nominal data, the distance between each category cannot be calculated, but the categories can be ranked above or below each other. No fixed units of measurements. For example, college football rankings, survey responses, that is whether a particular survey is poor, average, good, very good, or excellent. Then we have interval and ratio data. Both interval and ratio data are examples of scale data. Now, what is a scale data here? Scale data. Data is in numeric format, data that can be measured on a continuous scale. The distance between each can be observed, and as a result, it can be easily measured. The data can be placed in a particular rank order. Then we have interval data, ordinal data, but constant differences between observations. That is, a uniformly separated time series data. Ratios are not meaningful. For example, time that is moves along a continuous measure, or seconds, minutes, and so on, and is without 0 point of time. Temperature, we have then temperature moves along a continuous measure or degree and is without true zero. So this particular time and temperature are an example of interval data. Then we have ratio data. Ratio data is the data that can be measured on a continuous scale and it does have a natural 0 point. Ratios here are meaningful. For example, sales of a particular industry measured per month, delivery time, weight, height, and age. So these are the types of data that we have discussed, and these are the examples of what I have just explained to you. If I have a classifying data elements in purchasing database, and suppliers are category data, order number, item description, they all are category data. Then we have item cost, quantity, cost per order, they are ratio data. And then we have order date or arrival date, they are interval data. So this particular table specifies different types of data that we will use in our big data analytics. Then we have big data, this we have already discussed. There is four V's of big data. These are already discussed. Velocity, variety, which source of data represents the most immediate opportunity. Okay, big data opportunities, making better informed decisions, for example, strategies and recommendations, discovering, you know, hidden insights, that is anomalies, forensics, pattern trends, and finally, automating business processes, for example, complex events and translation, which is the biggest opportunity for big data in your organization. This is of no use. Yeah, identifying insurance fraud. This is application part of big data that we'll study later, not now. Okay, this particular slide shows that how big data can be used in business and analytics as well. Business intelligence is a broad category of applications, technologies, and processes for gathering, storing, assessing, and analyzing data. Now here, big data will be very much useful because business intelligence process and uses huge chunks of data to help business users make better decisions. We will implement big data analytics in business intelligence. Many companies are performing new kinds of analytics, that is sentiment analysis, to better and more quickly understand and respond to what customers are saying about them and their products. The cloud and applications are being used as data stores. Advanced analytics are growing in popular and importance. Now, here the concept of sentiment analysis is being discussed upon. Uh, Point number one, dear faculty, is if we see that what point number one is saying, it says many companies are performing new kind of analytics, that is sentiment analytics, to better and more quickly understand and respond to what customers are saying about them. Now you just open your YouTube page and you will see the videos of your interest. It is videos that are concerning with your interest. For example, if you see a particular video from a specific area, say sports, and when you again open YouTube, you will see many sports videos that YouTube will recommend for you, or that YouTube will suggest to you. So how does it happen? Or for example, you search for any product on Amazon or on Flipkart, and in the next time when you open that particular website, more products related to your search will be shown on your homepage. So how does it happen? Or I will just extend it furthermore. On Facebook, you add a friend that is from your school or college days. So after adding that particular friend, in the upcoming days, when you again open Facebook, there will be friend suggestions from you, from the same class from where you added that particular friend 2 days back. So how this prediction works? This particular phenomena is called sentiment analysis. That is analysis of the sentiments of a user, and this is a very important phenomena of big data and big data analytics, because what websites do, they just rate the views or the opinions of customers or users, and based on that they apply sentiment analysis algorithms using big data analytics and artificial intelligence. It's a combination of both. And based on those algorithms, this particular concept of sentiment analysis work. I will show you some content on this particular area as well, that how sentiment analysis work. You can go to any particular website, right click on that particular website and open its RSS feed. From there, you can see, or you can get the data that is required to perform sentiment analysis, or you can contact Amazon or Flickr or Flipkart. This is for if you want to publish a good paper in sentiment analysis using big data analytics. So I'm explaining you how you can do it. You can open any particular website, say Amazon or Flipkart, and you need a data set to be worked upon to build a predictive model or to build a sentiment analysis structure. For that, you can go to the RSS feed, and from there you can get some data that will be useful to you. Or option number two that you have, you can contact these websites like Amazon or Flipkart. They will provide you their data, but it is paid. They will you will have to pay some amount to the company, and they will provide you some data to perform sentiment analysis. So these are the options that we have to perform this particular work. Then we move forward, that is uncertainty of data. Again, the same concept, that is veracity of data, that ensures that the data that I'm using is authenticated and is from a trusted source. And these are analytics models: descriptive analytics, diagnostic analytics. Descriptive says what happened, diagnostic analytics says why did it happen, predictive analytics says what will happen, and then we have perspective analysis. It says that how can we make it happen. So these are the four basic parts of our analytical model in big data. Then we have descriptive analysis. Descriptive analysis, such as reporting, dashboards, and data visualization, have been widely used for some time. They are the core traditional business intelligence. It basically covers what has occurred. Business analytics like data visualization is important in helping users interpret the output from a predictive analysis, that is what has occurred. Then we have predictive analysis, algorithms for predictive analysis like regression analysis, machine learning, and neural networks have also been around for some time. That is what will occur, predicting what the future trend of a particular phenomena is going to be. And there are many approaches that are presently used by many PhD students around the world in this area. Like if I have the pattern of the spread pattern of a particular disease like Ebola, from a particular, from say 2015 to 2018, in a particular year span, if I have the spread pattern of a particular disease or anything like the purchase patterns of Flipkart, or purchase patterns or sale patterns, instead I should say sale patterns of Flipkart or sale patterns of Amazon for last 3 to 5 to 8 years, and I want to predict that what the sale patterns are going to be in the upcoming, say, 5 years or 8 years or 15 years, then to do that, it is possible. How it is possible? What this predictive analysis will do, it will, study and collect the behavior of the data of last 5 years. This phenomena is called training of the data, training set. It will take data from a specific period, say 2013 to 2020, last 5 to 8 years, as a training set, and it will train the system that how the performance of Amazon sale has been in last 7 years. And after training it, it will be able to predict that how the sale is going to be in next 3 to 5 years. So this is called predictive analysis, and we have many algorithms to do that, like LSTM or BPNN, GRU. These particular techniques are used to perform predictive analytics. And as you can see, again, we are just playing with the data. We are just playing with big data, that is huge amount of data. And if I have enough data for me to train my particular set, then I can predict the pattern or the flow of a particular information in upcoming 3 to 5 years. So this is predictive analysis. Then we have perspective analysis. Perspective analysis are often referred to as advanced analytics, often for allocation of scarce resources and optimization. That is what should occur. In the previous slide, we see that what will occur. Here, it will show that what should occur. That is, that perspective analytics can benefit healthcare strategic planning by using analytics to leverage operational and usage data combined with data of external factors like economic data, population demographic trends, and population health trends to more accurately plan for the future capital investments, such as new facilities and equipment utilization, as well as understand the trade-offs between adding additional beds and expanding an existing facility versus building a new one. So it basically means what should occur instead of what will occur. Then we have our organization transformation. Analytics are a competitive requirement for business intelligence based organizations. The use of business intelligence is a requirement for successfully competing in the marketplace. TDWI report on big data analytics found that 85% of the respondents indicated that their firms would be using advanced analytics within 3 years. IBM MIT Slogan Management Review Research study found that top performing companies in their industry are much more likely to use analytics rather than intuition across widest range of possible decision. Now here there is a very important trade-off: intuition versus big data analytics. What if I am executing or if I am operating a big business, okay, and I have, a huge amount of funds with me to spend. Where should I spend it? How should I spend it? whether I should spend it in building a hospital, or say I have a hospital, whether I should spend it on arranging more beds, or for purchasing new equipments, or for hiring new doctors. So these are the decisions that every businessman or every facet of the society has to make. And at this particular point, every individual will have two options. Option number one is intuition, which is a human behavior. Option number two is that that particular individual can use big data tools or big data analytics to precisely see that what is going to be profitable for him or his organization. So this particular example clearly and very specifically shows and explains you that how my big data analytics will be useful in real world scenario. I have the money, I want to invest it in my hospital. Where should I invest it? Whether I should go with my intuition, or I can use my predictive analysis or prospective analysis or big data analytics tools to find out that where it's going to be more advantageous in the upcoming years. So this particular example shows that how big data analytics can be useful in business intelligence as well as in real-time facets of the society. Then we have complex systems that require analytics, tackle complex problems, and provide individual solutions. Products and services are organized around the needs of individual customers. Dollar value of interactions with each customer is high. There is high level of interaction with each customer. For example, IBM, World Bank, and Halliburton. Uh, Volume operations also require analytics. It serves as high volume markets through standardized products and services. Each customer interaction has a low dollar value. Customer interactions are generally conducted through technology rather than person to person. They are they are usually analytics based. For example, Amazon.com, eBay, and Hertz. Then we have nature of the industry. Online retailers like Amazon.com and Overstock.com are high volume operations who rely on analytics to compete. When you enter their sites, a cookie is placed on your PC, and all clicks are recorded. Based on your clicks and any search items, recommendation engines decide what products to display. It is exactly the same thing, dear faculties, that I just explained you earlier. That is how sentiment analysis works in big data analytics. When I open a particular YouTube or Facebook page, our clicks are recorded. That is on which particular link or which particular page I have clicked, and that particular click will be recorded and stored, and its feedback will be provided. And based on the click patterns that a particular user has done, the future items are displayed to that particular user. So this is again the same thing that I explained you. Based on your clicks and any search items, recommendation engines decide whether that what products to display on your homepage. After you purchase an item, they have additional information that is used in marketing campaigns. Customer segmentation analysis is used in deciding what promotions to send. How profitable you are influences how the customer care center treats you. A pricing team helps set prices and decides what prices are needed to clear out merchandise. Forecasting models are used to decide how many items to order for the inventory. And finally, the dashboards monitor all the aspects of organizational performance. Knowledge requirement for advanced analytics, that is, what kind of knowledge we need for advanced analytics. Choosing the right data to include models is important. Important to have some thoughts as to what variables might be related. Domain knowledge is important to understand how they can be used. Role of business analytics is crucial. That is, consider the story of relationship between beer and diapers in the market basket of young males in convenience stores. You still have to decide or experiment to discover whether it is better to put them together or spread them across the store in the hope that other things will be bought while wa- walking through the aisles. So here it is basically going deep, that how the commodities or equipment should be placed in a particular business intelligence store. The findings were that men between 30 to 40 years in age, shopping between 5 p.m. to 7 p.m. on Fridays, who purchased diapers were most likely to also have beer in their carts. This motivated the grocery store to move the beer aisle closer to the diaper aisle, and instantaneously a 35% increase in the sales of both. So this is all the game of sentiment analysis, that what you can sell and how you can sell and how you can place them closer. This is just an example of that. Then we have visualization. Visualization means acquisition of insight. Many people and institutions possess data that may hide fundamental relations. Realtors, bankers, air traffic controllers, fraud investigators, engineers, they want to be able to view some graphical representation of that data, maybe interact with it, and then may be able to say that yes, it does work. For example, we see fraud. If I want to see that whether a fraud has happened or not, the Serious Fraud Office, that is SFO, suspected mortgage fraud. The SFO provided 12 filing cabinets of data. After 12 person years, a particular suspect was identified. The suspect was arrested, tried, and convicted. So this is an example of how fraud catching, or how we can find out the frauds using big data tools and big data analytics. Then we have the data was supplied in the electronic form. A visualization tool, that is NetMap, was used to examine the data. After 4 person weeks, the same suspect was identified. A master criminal behind the fraud was also identified. So, in controlling the crime as well, we can use the big data tools. Then we have, is information visualization useful? I think this is not in the context. Data mining, yeah, this is important. The process of semi-automatically analyzing large databases to find useful pattern. This is a formal definition of data mining. Areas of use are sales, marketing, diversify target market, identify clients needs to increase response rates. Then we have areas of use number two, that is risk assessment, that is identify the customers that pose high credit risk. Then we have fraud detection, that is identify people misusing the system. For example, people who have two social security numbers. Credit card fraud detections. Then we have detect significant deviations from normal behavior, that is finding out the network intrusion. Then we have customer care, that is identify customers that are likely to change providers. Then we have identify customer needs, and then we have medicine, that is match the patients with similar ailments and to provide the cure according to their ailments. Then we have data mining techniques, that is classification, that is predictive, Clustering, which is descriptive, association rule discovery, again descriptive, sequential pattern discovery, again descriptive, regression, that is predictive, deviation detection, that is predictive. Classification is the process of predicting the class from a new item, categorize the new item and identify to which class it belongs. For example, a bank wants to classify its home loan customers into groups according to their response to bank advertisements. The bank might use the classifications as response rarely, response sometimes, and response frequently. The bank will then attempt to find rules about the customers that respond frequently and that responds sometimes. The rules could be used to predict the possible requirements of those potential customers. Then we have techniques for classification, decision tree classifiers. I think we all have studied it, that we use a decision tree to classify a particular phenomena. Then we have applications of this particular classification, that is direct marketing. The goal is to reduce the cost by mailing, targeting a set of consumers likely to buy a new cell phone product. Approach is use the data for a similar product introduced before. We know which customers decided to buy and which decided otherwise. This buy don't buy decision forms the class attribute. Collect various demographic, lifetime, uh, lifestyle, and company interaction related information about such customers, type of business, where they stay, how much they earn, etc. Use the information as input attributes to learn a classifier model. Then we have application number two of this particular classifying, that is finding out the fraud. Goal is to predict fraudulent classes in a credit card transactions. Approach that we use is use the credit card transactions and the information on its account holder as attributes. When does a customer buy? What does he buy? How often he pays on time, etc. Label past transactions as fraud or fair transactions. This forms the class attribute. Learn a model for the class of the transactions. Use this model to detect fraud by observing credit card transactions on an account. Then we have application number three for this for this classification tool, that is customer or attrition churn. Goal is to predict whether a customer is likely to be lost to a competitor. The approach that we use is use detailed record of transactions with each of the past and present customers to find attributes, how often the customer calls, where he calls, what time of the day he calls the most, his financial status, his marital status, etc. Because all these will affect its buying patterns. Then we have label the customers as loyal or disloyal and find a model for loyalty. Means that the customers that will stick to a particular shop once they start buying from a shop. Then we have the algorithm for clustering. Clustering algorithms find group of items that are similar. It divides a data set so that the records with similar content are in the same group and groups are as different as possible from each other. For example, insurance company use clustering to group clients by their age, location, and types of insurance purchased. The categories are unspecified, and this is referred to as unsupervised learning. Then we have group data into clusters, that is, similar data is grouped in the same cluster. This similar data is grouped into a different cluster. How is this achieved? Hierarchical, that is, group data into T amount of trees and K nearest neighbor, a classification method that classifies a point by calculating the distances between the point and points in the training data set. Then it assigns the point to the class that is most common among its k nearest neighbors, where k is an integer, obviously. So application of this particular phenomenon, that is clustering, document clustering, goal is to find groups of documents that are similar to each other based on the important terms appearing in them. Approach that we use is to identify frequently occurring terms in each document, form a similarity measure based on the frequencies of different terms, use it to cluster. What gain we have is that information retrieval can utilize the clusters to relate a new document or search term to the cluster documents. Then we have application number two for clustering, that is market segmentation. Goal is to subdivide a market into distinct subsets of customers where any subset may conveniently be selected as market target to be reached with a distinct marketing mix. Approach that we will be using is collect different attributes of customers based on their geographical and lifestyle related information, find clusters of similar customers, measure the clustering quality by observing buying patterns of customers in the same cluster versus those from different clusters. Then we have association rule. Given a set of records, each of which contains some number of items from a given collection, produce dependency rules which will predict occurrence of an item based on occurrence of other items. For example, when a customer buys a hammer, then 90% of the time they will buy nails as well. So this is association rules. It is associating two particular buy patterns. For example, uh, bread, coke, milk, beer, and bread, beer, coke, diaper, milk. So these are the items that are bought together, or that we can say that are associated with each other. Association rule discovery application. Potato chips as consequent can be used to find out what should be done to boost its sales. Bagels in the antecedent can be used to see which products would be affected if the store discontinues s- selling bagels. Bagels in antecedent and potato chips in consequent can be used to see what products should be sold with bagels to promote the sale of potato chips. So these two products are associated with each other according to this rule. Then we have association rule discovery application number two, supermarket shelf management. Goal is to identify items that are bought together by sufficiently many customers. Approach is process the point of sale data collected with barcode scanners to find dependencies among the items. A classic rule is if a customer buys a diaper and a milk, then he is very likely to buy a beer as well. So don't be surprised if you find six packs stacked next to two typers. So this is a application of association rule. Then we have application number three of this association rule, that is inventory management. Goal is that a consumer appliance repair company wants to anticipate the nature of repairs on its consumer products and keep the service vehicles equipped with right parts to reduce the number of visits to consumer households. Approach that we use is process the data on tools and parts required in previous repairs at different consumer locations and discover the co-occurrence patterns. Then we have sequential pattern discovery. Given a set of objects with each object associated with its own timeline of events, find rules that predict strong sequential dependencies among different events. Rules are found by first discovering patterns. Event occurrences in the patterns are governed by timing constraints. For example, in telecommunications, alarm logs, inverter problem, excessive line current, rectifier alarm, and fire alarm. These are all, performed or executed in a particular sequence. Then we have in a computer bookstore, introduction to Visual C, C++ primer, and after that you will find Perl means advanced videos regarding to introduction to C or C++ primer. So there is a sequence between the tasks, and then we have athletic apparel store, shoes, racket, racket bolt, and after that we will have sports jacket. So there is a particular sequence or order in the events. Then we have regression, that is predict a value of a given continuous valued variable based on the values of other variables, assuming a linear or non-linear model for dependency, greatly studied in statistics, neural network fields. For example, predicting sales amounts of new product based on advertising expenditure, predicting wind velocities as a function of temperature, humidity, and pressure, and time series prediction of stock market indices. Now, see this last point, dear faculties. It says time series prediction of stock market indices. This is exactly the same phenomena that I explained you earlier. That is, if I have a data set of a particular phenomena for a specific amount of time, say 5 to 8 years, and I want to use that data through the years as time series. So that particular time series can be used to predict the flow or the pattern of data in the upcoming years as well. And this is very important and useful in stock markets as well, because as you know, stock market shares, it's a very fragile and unpredictable thing, and no one can surely say that the shares of a particular company or the shares of a particular firm are expected to go up or down in the upcoming 1 week or 2 weeks or even a month. So no one can predict that. So in this particular phenomena, this time series prediction using big data analytics is going to be very useful and important. What the PhD scholars or the researchers do, they just collect the share trends of a particular organization for a specific time period for say 5 to 8 years, and they feed that particular data as time series, and treating it as a time series, they train their particular model in fact, and then they are able to predict the behavior of the shares or the share market for a particular firm or organizations for upcoming 2 to 5 years. So this predictive analysis or predictive structure is very frequently used in stock market indices. Then we have your web mining. These are all, childs of your big data analytics, that is data mining, web mining, etc. Then we have web mining, discovering and analysis of useful patterns and information from the web, understand customer behavior, evaluate effectiveness of website, and so on. Web content mining, mines content of web pages. Then we have web structure mining, analysis links to and from web pages. And finally, we have web usage mining, that is, mines user interaction with data recorded from the web server. Then we have text mining, extracts key elements from large unstructured data sets that are stored emails, call center transcripts, legal cases, patent descriptions, service reports, and so on. And then we have sentiment and sentiment analysis software. Actually, it is not a software; it is a tool. Uh, Mines emails, blogs, and social media to detect and predict opinions. Then, uh, yeah. Then you move on to your next slide. Okay, then we have the upcoming slide that is large scale data management, big data analytics, data science and analytics, how to manage very large amount of data and extract value and knowledge from them. We have already studied that. What is big data? This is already studied. Characteristics of big data, that is volume. We have already studied that. Variety, velocity, already studied that. Big three V's. Some make it four V's as well. Yeah, some call it as three V's, some call it as four V's, but I think there are four major factors to big data rather than three. Now we have harnessing big data. First, we have OLTP, online transaction processing. Then we have OLAP, that is online analytical processing, that is like data warehousing. Then we have RTAP, that is real time analytics processing, that is big data architecture and technology. Who is generating big data? Social media and networks, scientific instruments, that is collecting all sorts of data, mobile devices, of course, sensor technology and various structures. The progress and innovation is no longer hindered by the ability to collect data, but by the ability to manage, analyze, summarize, visualize, and discover knowledge from the collected data in a timely manner and in a scalable fashion. Now, point number two exactly explained what I told you in the previous slide, that storing huge amount of data is not a problem, but to manage, analyze, summarize, visualize, and discover that useful information from that collected data in a specific amount and in a scalable fashion is the task that we are dealing with. The model has changed. As we can see that few companies are generating data, all others are consuming the data now. But in the new structure, all of us are generating data and all of us are consuming data as well. Because in the earlier age, there used to be newspapers, there used to be, manual sources of information, and very few data sources were there, and most of us were basically data consumers. But now there are online blogs, online websites, or online news sites, even live videos are there, so they all generate huge amount of data and they also consume it. So this makes the task a bit more tricky as well. Then we have what's driving the big data. As we can see, business intelligence that we have already studied, and predictive analysis that I explained you in the previous slide, and data mining. I explained you that as well in the previous slide. Uh, Ad hoc querying and reporting, data mining techniques. So these are the origins of the data from where this huge amount of data is being produced. Structured data, that is typical sources, small to mid-sized data sets. Then we move to data mining techniques, that is optimizations and predictive analysis, complex statistical analysis, all types of data, and many sources, very large da- data sets, more of a real-time data. Then we have value of big data analytics, means why it is important. Big data is more real-time in nature than traditional data warehousing applications. Traditional data warehousing architectures, for example, Exadata, Teradata, are not well suited for big data applications. Shared nothing, massively parallel processing, scale out architectures are well suited for big data applications. Then we have challenges in handling big data. Uh, this graph shows the growth of big data uh, with the years. The bottleneck is in technology. New architecture, algorithms, and techniques are required. Also, in technical skills, experts in using the new technology and dealing with big data are required. What technology do we have for big data presently? These are some of the big data landscape that we presently use: vertical apps, ad media apps, business intelligence, analytics, and visualization. And under these tabs, we have the organizations and technologies that uses big data as a service, analytics, infrastructure. So these are all uses or application or the organizations that use big data, and in the last tab at the bottom we see the technologies that we have for handling all these applications. Hadoop, uh, Hadoop, Map, Reduce, Mahout, HBase, and Cassandra. So these are some of the mostly or commonly used technologies of big data that we have. Then we have big data technology, big data, the moving parts. So this slide again shows that the growing patterns or the boom in use of the big data, that is fast data, big analytics, and deep insights. What you learn from this is we will focus on Hadoop and MapReduce technology, learn the platform, how it is designed and works, how big data are managed in scalable and efficient way, learn writing Hadoop jobs in different languages, that is in Java, C, and Python, and in high level languages, that is uh, Apache Pig and Hive. Learn advanced analytics tool on top of Hadoop, that is R Hadoop, that is statistical tool for managing big data. We will be studying all of them. Mahout, that is data mining and machine learning tools over big data. Learn state-of-the-art technology from recent research papers, that is optimizations, indexing techniques, and other extensions to Hadoop. These are some of the sources from where we can study these contents, and we will be explaining them in the upcoming slides as well. Let me just come straight to the point now. Yeah. Okay, some of the real-time examples of this particular technique. How much data? I have already explained to you that how much data are we presently dealing or operating with. Uh, yeah, the Earth scope. Let's study this thing. The Earth scope is the world's largest science project designed to track North America's geological evolution. This observatory records data over 3.8 billion square miles, amassing 67 terabytes of data. It analyzes seismic slips in the San Andreas Fault, sure, but also the plume of magma underneath the Yellowstone and much much more than that. So this is a ongoing science product which basically analyzes or studies the geological phenomena in North America, and it is amassing approximately 67 terabytes of data. This shows that how important our big data tools are in this huge amount of data sets. Then we have types of data, that is relational data, that is stable transaction, and structured data. I think we all have studied this relational data, that is SQL and DBMS are used in that. Then we have text data, that is web. Then we have semi-structured data, that is what do we do with these particular data, that is aggregation and statistics, data warehouse and OLAP, indexing, searching and querying, keyword based search, pattern matching, and then we have knowledge discovery, that is data mining, statistical modeling, uh, random samples and statistics. So this basically contains the statistical part. Population is used to refer the set or universe of all the entities under studies. However, looking at the entire population may not be feasible or may be too expensive. Instead, we draw a random sample from the population and compute appropriate statistics from the sample that give estimates of the corresponding population parameters of interest. Then again, we have statistics. This let SI specifies a random variable corresponding to a particular data point xi. Then a statistic theta is a function of theta s1, s2 up to sn belonging to R. If we use the value of statistic to estimate a population parameter, this value is called as point estimate of the parameter, and the statistics is called as an estimator of the parameter. Empirical cumulative distribution functions. So these are the mathematical part of data statistics and analytics. I will share the slide with you, and you can just go through it. Okay. Then we have OLAP and data mining, that is warehouse architecture. We have client. Client will do some queries and analysis. We have the warehouse, metadata, integration, and then we have the source of the data, uh, feeding into the integration and warehouse. Star schemas. Star schema is a common organization for data at a warehouse. It consists of fact table, a very large accumulation of facts such as sales, often insert only. Then we have dimension tables, that is smaller in size, generally static information about the entities involved in the facts. This is an example of the fact table. As you can see that it shows the product, sale, customer, and the store process of a particular organization. This is the star schema, as I explained you. This is the cube schema, 3D cube. That is when the data is stored in three uh, particular dimensions. Then we have ROLAP and MOLAP. ROLAP is relational online analytical processing, and MOLAP is multi-dimensional online analytical processing. Then we have aggregates. Uh, these are basic operations that we perform on our data and tables. Data mining we have already studied, and all these particular concept, that is decision trees, clustering, we have already studied in the previous slides. This is a very fine image that shows how clustering works. See, a specific amount of data is clustered in the age portion of this cube, and a specific amount of data is clustered in the right top corner of this cube. K-means clustering. This is a simple output of how our K-mean clustering, which is a data mining algorithm, uh, performs. Association rule mining, we studied that as well in the previous slide. Yeah. Then we have Data streams. What are our data streams? That are continuous streams, huge, fast, and changing. Why do we use data stream? The arriving speed of streams and huge amount of data are beyond our capability to store them, and specifically for real-time processing. Window models, that is landscape window, entire data screen, and sliding window, damped window, and at the last, mining the data stream. A simple problem is finding frequent items. Uh, this is again mathematical part. Yeah, this is. Yeah. So now we move on to our next slide. Yeah. Now we come to the tools that we use in Big Data and Hadoop. These are important to study the real-time architecture as well. And the hands-on practices that we'll do in the afternoon session, these are important for that. So we'll study them. Hadoop architecture, that is common Hadoop shell commands, anatomy of file, write and read, common Hadoop shell commands. Hadoop SDFS is a distributed file system. Hadoop SDFS is a distributed file system which provides redundant storage space for files having huge sizes. It is used for storing files which are in range of terabytes to petabytes. To learn more about world's more reliable storage layer, follow this HDFS. Let's continue with Hadoop HDFS commands. Hadoop architecture, common Hadoop shell commands, we'll be studying them now. So yeah, this particular slide shows some of the common Hadoop shell commands that are used. First we have path, that is start checking from the path. Then we have delete command, that is delete the corrupted files. Then we have files blocks, that is print out the block report. Then we have files blocks and locations, that is to print out the locations for every block. Then we have files blocks and recs, that is print out network topology for data node locations. Then we have files blocks replica details, that is for print out each replica details. Then we have files blocks upgrade domains to include snapshot data if the given path indicates a snapshotable directory. Then we have list corrupted file blocks. Then we have list corrupted file blocks, that is to print out list of missing blocks and files they belong to. Then we have move the corrupted files to found and lost. Then we have open for write, that is print out files open for write. Then we have show progress, that is to print out dots for progress in output. Default is off. Then we have storage policies, that is print out storage policy summary for the blocks. Then we have maintenance, that is to print out maintenance date, not details. After that, we have block ID command, which is used to print out information about the block. Get configuration command. These are some of the commands that we are using here. Name nodes gets the list of name nodes in the cluster. Then we have secondary name nodes commands that gets a list of secondary name nodes in the cluster. Then we have backup nodes, which is also a very frequently used command in Hadoop. It gets a list of backup nodes in the cluster. Then we have general nodes, gets the list of general nodes in the cluster. Then we have include file, gets the include file path that defines the data nodes that can join the cluster. Then we have exclude file, gets the exclude file path that specifies the data nodes that needs to be decommissioned. Then we have nnrpc addresses, gets the name node rpc addresses, and then we have the conf key to get a specific key from the configuration. Then we have Hadoop architecture. These are again few commands. I will share this PPT with ma'am and you so that you can just go through these frequently used Hadoop commands. Then we have our map reduce programming paradigm. Map reduce is a programming paradigm that was designed to allow excuse me. Uh, MapReduce is a programming paradigm that was designed to allow parallel distributed processing of large sets of data, converting them to sets of tuple and then combining and reducing those tuples into smaller sets of tuples. In layman's terms, MapReduce was designed to take big data and use parallel distributed computing to turn big data into little or regular sized data. Then we have the parallel distributed processing. Parallel distributed processing refers to powerful framework where mass volumes of data are processed very quickly by distributing processing tasks across clusters or commodity servers. With respect to MapReduce, tuples refer to key value pairs by which data is grouped, sorted, and processed. MapReduce jobs work via map and reduce process operation sequences across a distributed set of servers. In the map task, you delegate your data to key value pairs, transform it and filter it. Then you assign the data to nodes for processing. In the direct in the reduced task, you aggregate the data down to smaller sized data sets. Data from the reduced step are transformed into standard key value format, where the key acts as the record identifier and the value is the value that's being identified by the key. The clusters computing nodes process the map and reduce tasks that are defined by the user. This work is done in accordance with the following two steps. First one is map the data. The incoming data must first be delegated into key value pairs and divided into fragments, which are then assigned to map tasks. Each computing clusters a group of nodes that are connected to each other and perform a shared computing task is assigned a number of map tasks which are subsequently distributed among its nodes. Upon processing of key value pairs, intermediate key value pairs are generated. The intermediate key value pairs are stored, are sorted by their key values, and this list is divided into a new set of fragments. Whatever count you have for these fragments, it will be the same as the count of the reduced tasks. Then we have our step number 2, that is reduce the data. Every reduced task has a fragment assigned to it. The reduced task simply processes the fragment and produces an output, which is also a key value pair. Reduced tasks are also distributed among the different nodes of the cluster. After the task is completed, the final output is written onto a file system. A huge volume, velocity, and veracity of data by using map and reduce tasks to tag your data by a key and value pairs, and then reduce those pairs into smaller sets of data through aggregation operations. These operations that combine multiple values from a data set into a single value A diagram for the MapReduce architecture will be shown below. In short, you can quickly and efficiently boil down and begin to make sense of huge volume, velocity, and variety of data by using map and reduce tasks. To tag your data by key value pairs, I mean, whatever data that you are possessing at a particular time, that data will be tagged to a key and value pair, and then reduce those pairs into smaller sets of data through aggregation operations that combine multiple values from a data set into a single value. The diagram of the MapReduce architecture can be found here, and this is the diagram for a MapReduce architecture. As we can see that we are performing two tasks here. That is, one is mapping and another one is the reducing task. uh, then we have, if you are using MapReduce as a part of Hadoop solution, then the final output is written onto the Hadoop distributed file system, that is HDFS. HDFS is a file system that includes clusters of uh, commodity servers that are used to store big data. SDFS makes big data handling and storage financially feasible by distributing storage tasks along clusters of cheap commodity servers. Then we have map task. The Hadoop MapReduce framework creates a map task to process each input split. The map task uses the input format to fetch the input data locally and create input key value pairs. It applies the job supplied map function to each key value pair, performs local sorting and aggregation of the results. If the job includes a combiner, runs the combiner for further aggregation, it stores the results locally in memory and on the local file system, communicates progress and status to the task tracker. Then we have the map task. Map task results undergo a local sort by key to prepare the data for consumption by MapReduce task. If a combiner is configured for the job, it also runs in the map task. A combiner consolidates the data in the application specific way, reducing the amount of data that must be transferred to reduce tasks. For example, a combiner might compute a local maximum value for key and discard the rest of the values. Then we have the details of how map tasks manage, sort, and shuffle the results are not covered here. See the documentation for your Hadoop. This is documentation. When a map task notifies the task tracker of completion, the task tracker notifies the job tracker. The job tracker then makes the results available to reduce tasks. Then again, we have the explanation of the reduce task. The reduce phase aggregates the results from the map phase into the final output. Usually, the final output set is smaller than the input set, but this is application dependent. It means that that particular thing depends upon variety of applications. The reduction is carried out by parallel reduce tasks. The reduce input keys are and values need not have the same type as the output keys and values. The reduce phase is optional. You may configure a job to stop after map phase completes. Reduce is carried out in three phases: copy, sort, and manage. A reduce task, uh, these are the functions of a reduce task. It fetches the job resources locally, enters the copy phase to fetch local copies of all the assigned map results from a map worker nodes. When the copy phase completes, executes the sort phase to merge the copied output into a single sorted key value pair. When the sort phase completes, It executes the reduce phase, invoking the job supplied reduce function on each key value list pairs, saves the final output to the output destination such as HDFS. The input to a reduce function is key value pairs where the value is a list of values sharing the same key. For example, if one map task produces a key value pair that is EAT2 and another map task produces the pair EAT1, then those pairs are consolidated into EAT2, 1 for input to the reduce function. If the purpose of the reduce task is to compute a sum of all the values of each key, then the final output key value pair for this input is EAT3. Then we have MapReduce job to Hadoop. The local job client prepares the job for submission and hands it off to the job tracker. The job tracker then schedules the job and distributes the map work among the task trackers for parallel processing. Each task tracker spawns a map task. The job tracker receives progress information from the task trackers. As map results become available, the job tracker distributes the reduced work among the task trackers for parallel processing. Each task tracker spawns a reduced task to perform the work. The job tracker uh, receives progress information from the task tracker. The job tracker is responsible for scheduling jobs, dividing a job into map and reduce tasks, distributing map and reduce tasks among worker nodes, task failure recovery, and tracking the job status. Job scheduling and failure recovery are not discussed here. Yeah. Then we have when preparing to execute a job, what operations the job tracker will perform. It fetches input splits from the shared location where the job client placed the information, creates a map task for each split, assigns each map task to a task tracker, that is workers node. The job tracker monitors the health of the task tracker and the progress of the job. As map tasks complete and output becomes available, the job tracker creates reduced tasks up to the maximum enabled by the job configuration, assigns each map result partition to the reduced task, assigns each reduced task to the task tracker. Then we have the task tracker. The task tracker manages the task of one worker node and reports status to the job tracker. Often the task tracker runs on the associated worker node, but it is not required to be on the same host. When the task tracker assigns a map or reduce task to the task tracker, the tracker will do the following operations. It will fetch the job resource locally. It spawns a child Java virtual machine on the worker node to execute the map or reduce tasks. And it finally reports the status to the job tracker. Then we have the cluster setup. A Hadoop cluster is a special type of computational cluster designed specifically for storing and analyzing huge amount of unstructured data in distributed computing environment. Such clusters run Hadoop's open source distributing processing software on low cost commodity computers. Then we have basically one machine in the cluster is designated as the name node and another machine as the job tracker. These are the masters. The rest of the machines in the cluster act as both data node and task tracker. These are called slaves. Hadoop clusters are often referred to as shared nothing system because the only thing that is shared between the nodes is the network that connects them. Hadoop clusters are known for boosting the speed of data analysis applications. They also are highly scalable. If a cluster's processing power is overwhelmed by growing volumes of data, additional cluster nodes can be added to increase throughput. Hadoop clusters also have highly resistant to failure because each piece of data is copied onto other cluster nodes, which ensures that the data is not l- lost if a specific node fails. Then we have SSH and Hadoop configuration. The Hadoop control scripts relies on SSH to perform cluster-wide operations. For example, there is a script for stopping and starting all the daemons in the cluster. Note that the control scripts are optional. Cluster-wide operations can be performed by other mechanisms. To work seamlessly, SSH needs to be set up to allow passwordless logins for the Hadoop user from the machines in the cluster. The simplest way to achieve this is to generate a public-private key pair, and it will be shared across the cluster using NFS. Then we have the process. It is first generate a RSA key pair by typing the following Hadoop user account. This is to generate the key. Even though we want passwordless logins, keys without paraphrases are not considered as a good practice. It's okay to have an empty paraphrase when running a local pseudo distributed cluster as described in Appendix A that we will explain later. So we specify the paraphrase when prompted. For one, we shall use SSH agent to avoid the need to enter a password for each particular connection. The private key is in the file specified by slash f open, so it shows the path of a particular file. Next, we are required to make sure that the public key is in this particular path as shown in the slide. If the Hadoop user's home directory is an NFS file system as described earlier, then the keys can be shared across the cluster by just writing this particular Hadoop command. Test that you can SSH from the master to a worker machine by making sure the SSH agent is executing, and then run SSH add and store your paraphrase. You should be able to SSH to a worker without entering the paraphrase again. Now, then we have setting properties in a configuration file. Configuration files are best suited config for static configuration properties. By default, Apache Apache Hadoop looks for the configuration files in $Hadoop configuration directory. You may override this particular location by using your specific Hadoop command line that is explained below in the slide. So this was basically about map, reduce, and the function associated with this map reduce. Then we move to the next concept regarding Hadoop, and here we have managing resource and applications with Hadoop Yarn. Yarn stands for yet another resource negotiator. It was introduced by Hadoop 2.0 to remove the bottleneck on job tracker, which was present in Hadoop 1.0. Yarn was described as redesigned resource manager at the time it was launching, but it has now evolved to be known as large-scale distributed operating system used for big data processing. This is Hadoop 1.0 architecture. Uh, this is Hadoop 2.0 architecture. As we can see that Yarn has taken a very important place here. Yarn architecture basically separates resource management layer from the processing layer. In Hadoop 1.0 version, the responsibility of job tracker is split between the resource manager and application manager. Yarn also allows different uh, data processing engines like graph processing, interactive processing, stream processing, as well as batch processing to run and process data stored in HDFS, thus making the system much more efficient. Through its various components, it can dynamically allocate various resources and schedule the application processing. For large volume data processing, it is quite necessary to manage the available resources properly so that every application can leverage them. Then we have managing resources and applications with Hadoop Yarn. Yarn gained popularity because of the following features. These are some of the characteristics of Yarn. Scalability, the scheduler is in the resource manager of Yarn architecture, allows Hadoop to extend and manage thousands of nodes and clusters. Compatibility, Yarn supports the existing MapReduce application without disruptions, thus making it compatible with Hadoop 1.0 as well, which is very important because if you are using a particular application then we have the Hadoop Yarn architecture, the way it works. The main components of Yarn architecture include, first one is the client, that is it produces and submits the map reduce jobs. Then we have the resource manager. As we can see here, this is the architecture of a yarn, and we will be now explaining one by one every part of this particular architecture. First, I told you the client, what is the function of the client. Then we have the resource manager. It is the master daemon of yarn and is responsible for resource assignment and management among all the applications. Whenever it receives a processing request, it forwards it to the corresponding node manager and allocates resources for the completion of the request accordingly. It has two major components. First one is the scheduler. It performs scheduling based on the allocated application and available resources. It is a pure scheduler, means it does not perform other tasks such that monitoring or tracking, and does not guarantee a restart if task fails. The Yarn scheduler supports plugins such as capacity scheduler and fair scheduler to partition the cluster resources. Then we have the application manager. It is responsible for accepting the application and negotiating the first container from the resource manager. It also restarts application manager container if a task fails. Then we have the node manager. It basically takes care of individual node on on a particular Hadoop cluster and manages the application and workflow that and that particular node. Its primary job is to keep updated with the node manager. It monitors resource usage, performs log management, and also kills a container based on directions from the resource manager. It is also responsible for creating the container process and start it on the request of application master. Then we have the application master. Means what is an application master? An application is a single job submitted to a framework. The application manager is responsible for negotiating resources with the resource manager, tracking the status and monitoring process of a single application. The application master requests the container from the node manager by sending a container launch context, that is CLC, which includes everything an application needs to run. Once the application is started, it sends the health report to the resource manager from time to time. Then we have our uh, yeah, application workflow in a Hadoop yarn. This is the application workflow. Now, this is the image, and I will now explain you how these applications work. Client submits an application. As we can see here, client will submit the application in our step number one. As you can see, the step numbers are also mentioned. Then the application manager registers itself with the resource manager in our step number two. Then the application manager negotiates containers from the resource manager. The application manager uh, notifies the node manager to launch containers. Application code is executed in the container. Client uh, contacts the resource manager, application manager to monitor application status. Once the processing is complete, the application manager unregisters with the resource manager. So this task flow is also shown by the numbers specified in this image. So this was basically yarn that how yarn works. So in the afternoon session, we will, continue with this study, and we will continue. We will study some more and important topics regarding this particular area of Hadoop, and along with that, we will also Yeah, and along with that, we will also study some of the open research areas in big data analytics and Hadoop. I will also show you one of my patent that is recently being accepted in this area. Uh, that is Hadoop architecture, and combining Hadoop with artificial intelligence. And from that, I will try to present you an idea that how we can use this big data analytics and Hadoop in our AI applications, and we can use this area to file good patents and good research papers, and we'll do some hands-on practices as well. So I just look forward to join you again in the afternoon session. So now I hand over to ma'am for the upcoming proceedings.
Participants, if you have any queries, you please ask. Um, so I think so. No queries from the participant side.
Okay,
Okay, sir.
ma'am.
We will start the session again at 2 o'clock, sir. Now we will end the session.
Thank you very much, ma'am. Thank you.
Okay, sir. So, thank you. Again, the session will start at afternoon 2 o'clock. I request the participants to join before 10 minutes. Thank you.